Hi, grade 11. Okay, today we will talk about, or we continue talking about the electrolysis, okay? Where the electrolysis, as we know, a technique used to split the compounds into their elements by using electricity, where electric current passing through electrolytes. So the ions of electrolytes have been free, so they can conduct electricity. In this part of curriculum, we will talk about the electrolysis of aqueous solution of ionic compound, okay? And this is depend on the chemical activity series, where the chemical activity series defined as a series in which the metals are arranged in descending order according to chemical activity. Look at the screen in front of you. This is a chemical activity series where the most active metal, okay, put at the top of the chemical activity series, so the activity decrease gradually until reach to the last one where the platinum is the least reactive metal, okay? In chemical activity series, any metal, okay, lie precede the carbon, it considered the most active metal. So potassium, sodium, calcium, magnesium, aluminium are most active metal, okay? Zinc, iron, tin, lead, less active metal, and after hydrogen we have copper, silver, gold, platinum, okay, which is known as poor active metal, okay? So, insoluble salt or insoluble ionic compound in water, it will form aqueous solution, okay, and it will form electrolyte used during electrolysis. So, in electrolysis, we used beaker that contain electrolyte, and we also need two electrodes. One of them is known as anode that represent the positive electrode, while the other is known as cathode that represent negative electrode, and the wire to connect the two electrodes to the battery. In aqueous solution of ionic compound as copper sulfate, the water ionized into hydrogen positive ions and hydroxide negative ions. And the copper sulfate also ionized into copper positive ions and sulfate negative ions. We have a rule of electrolysis in this case. The cathode negative electrode attract positive metal ions and hydrogen positive ions that produced from ionization of water. But cathode will only discharge one, okay? So the ion of the least reactive element will be discharged according to chemical activity series, okay? If the metal produced during electrolysis is less active than hydrogen, so it will be discharged at cathode, okay? But if the metal is more active than hydrogen, the hydrogen in this case will be discharged instead of metal positive ions, okay? At anode, the anode represent, as we know, the positive electrode during electrolysis. We have the same problem where anode attract two types of ions, two negative ions, okay? Negative ions, hydroxide negative ions, okay? And the negative ions are produced from ionic compound. But if negative ion is halogen or halide, okay? Halide or halogen, the group 17 in modern periodic table that include fluorine, chlorine, bromine, iodine elements, okay? The halogen in this case will be discharged, but if the negative ion is not halogen, always hydroxide negative ions will be discharged, forming water and oxygen. Okay, so Again, I will repeat again, electrolysis in aqueous solution don't contain halogen. Number one, hydroxide ions migrate to anode where they are oxidized and oxygen gas evolved. Where the less reactive metal, according to chemical activity series, migrate to cathode. Electrolysis of aqueous solution of ionic compound contain halogen. There are two cases. Electrolysis of dilute solution, okay, we apply the same rule in A. Electrolysis in concentrated solutions, the halogen migrate to anode and the less reactive metal migrate to cathode. Okay, let's start the first example, the electrolysis of copper sulfate aqueous solution. Okay. What happened? The copper sulfate ionized into copper positive ion and sulfate negative ion. Also water ionized into hydrogen positive ion and hydroxide negative ions. Okay. At cathode, the negative electrode, the copper positive ion and hydrogen positive ion will be attracted to cathode. Okay. And according to chemical activity series, we note that copper is less active than hydrogen, so it will be discharged at cathode. That means it gets 2 electrons from cathode because cathode covered with electrons, and it change from copper positive ions into copper pure element that accumulates around the cathode electrode. And at anode, what happened at anode? It attracts hydroxide negative ions produced from ionization of water and sulfate negative ions produced from copper sulfate. As we know, hydroxide ions will be discharged because halide is not present, where hydroxide lose electron at anode and change into oxygen and water. The equation will be 4 hydroxide negative ions change into 2H2O and oxygen molecule plus 4 electrons that migrate into cathode by using wire. Okay. Another example, the electrolysis of aqueous solution of sodium chloride. Okay. In electrolytes, we have sodium positive ion, chlorine negative ion, hydrogen positive ion, and hydroxide negative ion. At cathode, the cathode will attract positive ions, sodium and hydrogen. But in this case, sodium is more active than hydrogen according to chemical activity series. Okay, so the cathode can discharge hydrogen ions, okay, by gaining electrons and they change into hydrogen gas. Okay, but at anode, the anode attracts hydroxide negative ions and chlorine negative ions. Okay, remember that chlorine is a halide from halogen, from group 17, group of halogens. Okay, so according to the rule of electrolysis, it will be discharged at anode by losing electron and they change into chlorine gas. Okay, thank you, grade 11. Okay, and goodbye.